to the audience. My name is Subodh Kumar. I manage a solution architect team for emerging technology at Amazon, with machine learning, edge computing, quantum computing, high performance computing, and blockchain being some of those. Very excited to be here. This is my first presentation with Ron's team, and I'm hoping this is going to be valuable, and I come here again. A little bit about this morning. So Blue Horizon, New Shepard went up and landed. So that's an exciting moment, and there's a whole bunch of things in that is related to what we are talking today in my session and follow-up sessions with others in this area. So it's an exciting day for machine learning. The audience is at different levels, I'm assuming. So I have tried to keep this from basic fundamental to some of the to introduction to quite a few services that Amazon has, and hopefully you will learn what machine learning is at a very elementary level, and then take it on to what Amazon provides in terms of services to make this simpler and useful to enterprises. So with that, taking off. Just there are certain things that machine learning needs, and so I want to set the background with that. You need to have, so machine learning is all about data. So basically an organization has data. We used to do analytics off the data in data warehouses and Tableau and others were there, BI tools were there. Now, the natural progression is to use the data to draw intelligence or conclusions, and that is what machine learning is. To taking that premise forward, if an organization needs to be successful at machine learning, a few things need to happen. First of all, your data needs to be, I say data was in silos, and now we can say as long as you can open the data silos to be able to integrate the information from those, that's good. Doesn't mean that every data silo needs to be merged and made a single data warehouse or a lake, but the data silos must be open to have the most productive value of ML. The second is data should be easily and securely accessible. The first thing that happens when you open the data silos in many organizations is security, because the data belongs to different parts of the organization. There might be sensitive data. How do you secure that data if you're just opening it up or centralizing it? That becomes a challenge too. And finally, of course, once you have the data opened up and secure so that people can use it, then putting it to use to make decisions, and that is where ML comes in. This talks about exactly the same thing: modernize your infrastructure, liberate the data, and then finally innovate with ML. Those are the paths to data-enabled organization. So that was just a background to see what is, how does an organization move along its data journey and uses the data for the business decisions. These are some of the use cases, very, very high-level examples. As I said, we are now traveling in space and at the edge of space, and ML plays a huge role in that, machine learning. But there are many cases on the ground that are using ML, and this is just a few examples, and some of our partners. Intuit being one. They use call centers, machine learning in call centers. Call centers, the effectiveness of call center employees is dependent on the amount of information that you provide to the employee about the person or customer who is calling. Sometimes it's just data. Sometimes it's also sentiment. Is this a customer who is very frustrated because they had relatively bad experience in the past? They're frustrated because things are not working. All those sentiments actually input value to the call centers. So that's one where ML comes in significantly with not only data collection and interpretation of data, but also about the sentiments of the call. Of course, transportation logistics is one of the things we do. Amazon moves around goods across the world, and our transport logistics tries to get it in the fastest amount of time to you. And that uses tremendous amount of machine learning to optimize the path. One thing that we realized during COVID is healthcare. Healthcare, in general, if you see a drug research used to take tens of years. This time, cloud providers and ML combination has created a significant insight into drug discovery that has shown as practical implementation in COVID. And if you really look at the amount of time it took to, I mean, we wanted it earlier, but the amount of time it took to get the COVID um, uh, drugs or vaccines in place, it's impressive. That we can all say with confidence. And finally, something in entertainment, NFL uses the ML to take the real-time data and provide entertainment and information to the people who are looking at the player performances, predicting who is going to win, and so on and so forth. That's the background of uses. In general, ML is growing, and this is some data point. By 2024, global spending on AI will reach about 110 billion NSB. From piloting to operationalization, a lot of organizations are in or were in piloting stage about 4 to 5 years ago. But by 2024, a lot of those organizations who were toying with the idea of ML will be putting it in operation. About 75% of those will shift from piloting to operationalization, as Gartner says. And finally, AI transformation. Almost about 60% of the organizations said that that AI would transform their organization in the next 2 to 3 years. The message is that if the organizations who are not looking at it will probably be left behind in next 4 years, and almost every organization realizes that. Just consolidating the message, you can transform customer experience, improve business operations. These are some of the use of ML, but it's way broader than this. Amazon uses ML at scale, and we have been using ML for a long time. That is why we are able to address purchasing of goods, putting them in warehouses, sorting them out, getting them on the belt, packaging them, and shipping them in the optimal amount of time. All that would not be possible without ML and bots being together. So this is some of the data that you see. One of the other thing is Alexa. Quite a few people might have Alexa, Echo, or something like a bot. It doesn't only have to be Amazon, but bot, which actually you're using significant amount of ML behind it. When you talk to it, what happens to your voice? How does it get translated into, say, text? Then based on what you say, how does the response get prepared, and then how is it spoken back to you in possibly the language of your choice? Some of those things that Alexa does in the back, ML plays a significant role there. And then, of course, we in December 2016, we started the primary delivery with drones. Huge amount of ML in that, in terms of the ML at edge, as we call it, sensors giving where the drone is at this point, finding out where it needs to go, finding out the traffics, finding out the air, finding out obstructions, all those things. These are some of the places where ML has really started showing us the direction. And we have about we have many customers. How about that? 100,000 is data that's from 2021, and it grows every day from many companies. Ton of partners. Actually, we just had Jim talk about UiPath, one of our partners in terms of robots, RPAs, and in terms of intelligent robots, he actually talked about integrated AI, which plays significantly in automating the robots these days. All right, so now that we put the context of ML behind, let's see what it really is. And this is probably for 100 level. So some of the audience might find it very repetitive. So bear with me, it'll get more interesting as it goes. And if people who are not familiar with ML, this will be a starting point for them. So what is ML? Traditional programming, you put data, you put program in a computer, and out comes the result. You have a Java program, you have a Python program, you have a C program, which has the logic already in there, which is what we call as program. You drop some data. It's like, okay, fine. What is just gonna pick up 35 plus 90, and then out comes the number 125. Because the program knows how to add 35 plus 90. In ML, if you look at the logic, it's a little bit different. You put data, you drop the output in it, and out comes the program. So basically, a programmer or others, even business in that case, who used to put the program logic in how to move how to decide which customer you want to give how much rebate. That was a program. If the customer pays this much, then or buying this much, then this is the rebate. Well, that program in ML is an output of what we have done in past and what was the output. And then it infers from there what the program should be. It'll become clearer as we go through. So what does this program actually look like is what it is. So this is just a glimpse. This is not telling that this is what ML is limited to, but just giving you what the program does. So first chart, bunch of data. So we put the data in it. We said, okay, this is what the data looks like. And the program is just drawing what the graph or the line looks like. And it basically creates a formula out of it. Next time you put a data point in that, it applies that formula and gives you an output along this curve. Maybe this is the curve of your return on investment of certain things. The other part, the middle chart, shows another kind of learning a program. Is basically you have different data and you think that, okay, red one is one segment of your customer, black is another segment of customer, green is another segment of customer. They have certain habits. The program will learn to kind of segment those three using these lines. Basically, what the program is learning is what are these three lines. And next time you drop a point on this screen, it'll know whether it belongs to the black segment or the red segment or the green segment. And the third one just shows that what we call as tree. We use that a lot manually, and we have been using trees for about 30, 40 years, not through ML, but in general. Whether you say, okay, fine, I have certain pieces of information. If it is true, if you go from top to bottom, if it is true, then do certain things. If it is false, then do something, and then you can continue down the tree. This is basically what if-else logic. If you look at nested, that's what it should happen. That's what it is. So this is what an ML program looks like. It could be a graph. It could be a line that it figures out what is the best line or curve fitting, as we call it. It could be segmentation, as it figures out, like, okay, where does the boundary of black, green, and red? Or it tells you, okay, fine, it figures out what are the branching in the trees in your tree logic. Pausing to make sure that I didn't go fast. Carlos, looks okay?
You're right on time. You're doing great.
Okay, thanks.
Yep.
All right, so we said that ML is takes data and takes output and creates a program. Very intelligent, right? It's very smart. Well, is it? Let's see. We said data and output goes into the computer and out comes a program, right? What about this? What if your data is biased? So the amount of data that you provided, it belongs to one section of your customer. You only provided the system data about the customers who are spending over $3,000 on your product. Just picking an example. Well, computer will assume, or program that will come out will never know about the customers who spend less than $3,000. So if the data is, well, I can also call it incomplete data, or if your data and output are biased. If you are defining that a person who is, I'm a short guy, so I'm going to take this example. A person who is 7 feet tall is the smartest in the world, and that is what your output is going to look like. So every time you say, okay, fine, a person who is taller than 7 feet is smart, and that's how your data and output relate to, the program is going to learn it that way. That's called biases. And if your data has bias, the computer will learn a program in the bias way. It's like teaching a child If you give them a certain piece of information over a period of time, they'll learn to behave, to interpret it in a certain way. So biases in your data or your output can drive what program learns, and MLs are extremely sensitive to that. There are many horror stories of ML in that. If your data is incomplete, your program will learn incomplete information. This is why ML picked up a lot when the amount of data and then amount of compute required to process the data started becoming more accessible. So today, I'm dropping cloud here. If you look at the amount of data that's exploded in the cloud and amount of compute capacity that is in the cloud, that enables a lot better programs in ML than if you had two computers and 100 gig of data. Today, even there are data exchanges. Even Amazon has something called Amazon Data Exchange, which picks data from a lot of surveys that happen around the world, pharmacy data, patient data, anonymized, of course, weather data, all those pieces of data. And we inject that data into defining a program that is smarter. And finally, this is interesting. So if the program only learns from data and output directly, if you only feed it historical data, it only knows how the system behaved in past. If your future behavior of the system is going to change, program will take some time to learn that. Basically, the program stays a little bit behind the data that comes in. This is where if you want program to behave in a certain way, then you will have to create some data that represents what the program should do. And then feed that with a label. We will talk about the human in the middle, which plays significantly in that. So as long as your business logic is following the trend that historical data has suggested, you're fine. But if the trend changes, then ML programs have a little bit of difficulty to catch up. With that, I wanted to look on the right side of it. Okay, fine. So we fed data and output. We fed data into the program, fed the output related to that data in the computer, out came the program. All these biases in the bottom take care of. Ultimately, what you want is once you have the program, the logic goes back to what the traditional computing used to do. Now you have what we call it inference. So you drop that program that the system learned, and then you drop a data in it. So your system, you provide a system a bunch of logic about about your customers. The computer came out with a program that defines what type of customers you have and what kind of product you should sell to them. The program is ready to go into production and infer. So now you put new data points about, hey, this is the customer. It will give you output about recommendation of products that you should go to that customer. Okay, cool. A bit of confusion or some terminology that is used interchangeably, but actually are a little different, or they have final subtle differences. So artificial intelligence, just to clarify, artificial intelligence is anything, a technique that mimics human intelligence using logic. It could be anything. It could be ML related logic. It could be if then logic. It could be a bot which takes up repetitive work. That's all artificial intelligence. One of the ways artificial intelligence learns things is by machine learning, where you are it is deriving the logic and learning continuously. And one of those ways in which machine learning algorithm works is what is called deep learning, which is you have huge amount of data and learn some complex logics. We will not talk about deep learning today, but I just wanted to make sure that there's no confusion on the terms that I used. And again, it might be repetitive for a lot of audience. Okay, getting into, so we talked about taking the data, taking the output, dropping it in, and creating a program out of that, and then using that program to make business decisions. AWS, actually, its whole stack, as we will talk about, enables the developers, the business users, and data scientists to use ML. And as you will see, they are at different skill level, or they have different different approach to the problem. Data scientists, while they are looking at defining different complex algorithms as to looking at the data, what should it do, what should the program look like, developers will use those algorithms and develop what we call as a production pipeline. They will need the data because that's the first part of it. You might need to prepare the data, sanitize the data, drop it through the algorithm, make sure the algorithm is doing right prediction, understand that algorithm, verify that the algorithm is doing the right prediction, right output, and then take it to production. Now that algorithm is doing fine and you have verified is doing fine, the program is ready, you drop it in production. And then there comes a lot of CI/CDs. How do you, let's say it's a fraud detection system. Now you have a fraud detection system going into production. How do you make sure that the transactions that come through bank or ATM or your credit card swapping machine, how does that transaction flow through now this fraud detection system to give you input? What do you to give you output, whether it's fraud or not? What do you do with that output? Do you take that output and decline somebody a purchase money, or do you just do something else? Do you do risk assessment? All those things are part of the whole ecosystem. So basically, data scientists, while they develop the algorithms, developers are responsible for going pre-algorithm, preparing data, making sure the data is right, dropping it into the algorithms, doing feature generation and others that we'll talk about, and then taking that output from the algorithm, deploying it into production to make sure that business output comes out of that. Then you comes the business users. Business users are you have seen a lot of people using spreadsheet to do graph fitting, curve fitting, and all other things in making decisions. How do you make sure that these algorithms or ML, the output that's created, programs that are created, are directly usable by business users? And these are three different type of users. If you really look at the industry, there is a very small set of very smart data scientists. There's a larger set of business developers, and there's a very large set of business users. Making sure that all these are addressed is going to be very important for ML to be useful in creating value for itself. So with this background, I wanted to move forward. So to address those, AWS has a ML stack, which actually comes in three sections. If you really look at it, these are logically sectioned. The bottom layer, as we call it, is called ML framework and infrastructure. This is for data scientists. There are deep learning framework in that. There are containers. There are processing engines in that, like GPUs, CPUs, FPGAs. There are different specialized machines in that with inferential chips, elastic inference, or there are frameworks, as we call it, TensorFlow, PyTorch, MXNet, and many others, Hugging Face. So this is for data scientists, the bottommost layer, where people will apply the mathematics and statistics to create an algorithm. Or some of the algorithms are generated and pushed up to the higher layer. So the bottom layer pushes the algorithm to the higher layer. The middle layer is for developers, which is Amazon SageMaker. If you go from left to right, you will see that it says, okay, label data. So we said ML requires data, it requires output. Well, which data has what output, which customer spent how much is something that, or which transaction is fraud, is what is called labeling. And that labeling needs to happen for a type of ML algorithm called supervised learning to be able to draw the program logic out of it. So labeling data is a part of it. That's just on the left of it. And then you do data collection, data preparation. You have features. You derive features out of it. You store the features. You make sure the data doesn't have biases, as we talked about. 7-feet person is more smart than a 5-feet person like me. So you make sure the data doesn't have bias. You need to have a mechanism to detect that. Then you visualize the data. Make sure the data looks right. It represents your business customers well, just to understand that you don't have a lot of anomaly in the data. That's that. Then you pick up an algorithm that's generated at the layer below this. Then you train your model. Train your model to optimize its performance. Train your model to make sure that it gives you the right output. Then you tune the parameters. They're called hyperparameter tuning. So a model depends on a whole bunch of hyperparameters. Some of these will be um, how many rounds of training do you want to do? It'll be do you want to adjust the system for some outliers? Things like those are part of tuning the parameter. And then once you are, there's also something called validation in that. So tuning a parameter and validation together you can do. Then you deploy the program in production. Once you deploy it in production, then you have issues about your business logic might change, your data patterns might change. How do you make sure the program that you deployed in production is still effective? It's manage and monitor. And then, of course, in many cases, you will drop it into an edge device, which could be Alexa, which could be your Nest, which could be um, uh, your car, any of those things. How do you push that algorithm onto the edge device so that they can make smart decisions? I walked this through very fast, but the whole purpose of talking about middle layer is basically a developer's paradise and very complex. It is not just drawing algorithms. That's one part of it that scientists do. But taking that algorithm, making use of it and making business decisions is a complex exercise, right? From leveling the data, preparing the data, all the way to making sure that the algorithm works, making sure that you have the right algorithm, making sure the algorithm is tuned properly, making sure that the algorithm performs properly, and also making sure that algorithm that you put in production is still effective and it has not drifted away, as we call it. And then finally, pushing that algorithm out to maybe edge devices. This is where we say that when we said in 2020 by 2024 57% of the of or 75% of the organizations will push it to production. For last 5 to 6 years, about 10 years, different uh, the algorithms are being developed, but a large part of organizations are still on a journey to say how to utilize these algorithms or knowledge that we have achieved into generating business value out of it. And it's a very time-taking, complex job. A lot of tools are required for that, and the middle layer of SageMaker Studio IDE basically integrates all that and makes it user developer friendly. At this layer, you may not need to know all about what the algorithm does, read the research paper, but as a developer, you should be able to take that the data and then start creating business value out of it. Dumped a lot of information in you. The last part is for business users. This is where we have taken data from relative field, like we have millions of customers. We know about what customers prefer. We recommend services to the customer, product to the customers. We have other partners, Netflix, who recommend movies to the customers. All that information we have, all that data that we have used that data to create the model or program, as we call it. And we have taken care of hosting that program in a place in terms of a service. So all a business user has to do is throw that data onto that service and then get a result. So for a business user, it's just calling a program that's already tuned, already hosted, and then just get an answer. Some of the example would be vision, right? Uh, vision or recognition part of it, face recognition, object recognition, car recognition, number plate recognition, um, uh, in terms of interior decoration, recognition of objects, fabrics, and other things. All those things are complex algorithms that originate from the bottom layer, and there are many algorithms for that. But our recognition software or hosted software, if I can call it, basically takes the bottom part of defining the algorithm, optimizing the algorithm, and then takes the whole CI/CD pipeline, hosts it in a place, and say, okay, fine, now you can drop the data, and we'll give you what it is. It also ensures that we understand that some of the objects that are probably specific to you, like your company's logo, may not be directly recognizable. So we give you in space to define what we call as custom level, basically your data and your output. So basic 98% of the program is already ready. But if you want to tweak it to your company's specific needs, you can customize that too. And going from left to right, there are many. There are Poly, there are Transcribe, there are Lex for the chatbots. They are comprehend, who understands the mood of a sentence or a paragraph. They are translate, which takes data from or audio from I should transcribe that. The translate, which takes the data in one language, can translate into another, so on and so forth. Business tools, things like personalize, which actually says, okay, fine, how do you take your business and customize it to everybody, depending on what their purchase pattern, what their feedbacks and other things were. Or forecast, how do you take your company's cost or spendings and then forecast in terms of budget? Or how do you take your labor costs at this point and forecast what the labor cost would be? And it takes care of seasonality, it takes care of weather, all those pieces in it. Or fraud detection. We have search capability for ML, which the next session is going to talk in more detail about. Or sometimes it's just industry related. If you look at Health Lake, we have created a Health Lake itself, which basically is shaped or designed to ingest the healthcare data, understand the healthcare data, and give output. We have Comprehend Medical, which takes the prescription from or doctors' write-ups and things like that and understand what it means. If you have seen doctors' write-up, you will understand how valuable it becomes. Or in certain cases, industrial, like we call it Panorama Appliance, look out for vision, look out for equipment. Basically, in general, what they do is, let's say you have you own a factory or industry, and you create. I'm just going to pick one. Um, glass glass equipment. Now, there are two things that will happen. Your equipments might wear out. So for that, you have look out for equipment. It's a hosted service. You take your data, you feed it to that endpoint, and it'll tell you if your equipment is wearing out or not. Or your glass products might be defective. At certain point, it might start producing different defective results. And Lookout for Vision is a hosted service where you point the data, it will tell you based on your historical data, this one looks defective. The reason for dropping a whole bunch of information in you is all you need to take is there. At the bottom layer, you have data scientists who are building the algorithm. At the middle layer, we service the developers who take the algorithm and drop it in production. And at the top layer, if you don't have any of those and you really want to have quick value, we give you the AI services which can directly be used by business users.
Excellent stuff, Subodh. And thank you for all that great information. I see we have some questions on the chat. What I would like to do is I'm going to move forward and put Murdy. But at the end, when all three of you are done speaking, I'm going to bring all three of you up, and then we can answer some of the questions that are in the chat. Does that sound good with you?
That sounds good.
Thank you.
Do I have one more minute? I might be going over. Just to conclude.
You're a little bit over, but you can finish up. Yeah, you can wrap it up.
Okay. All right, fine.
We'll bring Murdy on board.
Okay, I will rush through and finish it up. So this is talking about exactly the same thing. The bottom layer is for the scientists. Middle layer is for developers. Top layer is for. We'll continue through. We'll just mess through. This is just to give a picture of how complicated the taking it from business problem to solution and then monitoring the solution is that we talked about. And it says all these things are part of SageMaker. So it simplifies that by having a view of going from left to right, prepare the data, build the algorithm, train and tune the algorithm, deploy and manage the algorithms. Some of the benefits are accelerate development, boost your data scientist productivity at the lowest layer, reduce the cost. Basically, if you have straight away a business user, they can just use that, the services that we host. It does help with a whole bunch of things that you need to do. If you're hosting a full IDE pipeline at your place, security, compliance, workflows, scalability, orchestration, all these are the problems to solve. SageMaker has that all built into it. Okay, and taking forward, just this is the last layer where we said, okay, I just want a business solution. For the business users, just hit the top layer. These are the industry solutions that we talked about. And if you are starting on ML journey, then start with training, proof of concept and production, and AWS helps you with all that. We have certification program. We have course content that you can use for training. We have ML Lab, which is a lot of which is a group of data scientists which will come look at your business, read your business, and give you a proof of concept of the solution, and then train your people to pick it up and then take it to production. If you want to test your team's skill, we have after training, so we have quite a few competitions there. We have Deep Composer, where you can test out making new music. We have Deep Racer, where you can test out how to do reinforcement learning using cars. We have Deep Lens, some of these things, and then we have certification courses. We have Solutions Lab, which actually helps you build a prototype in your organization and take it through, then train or hand off those the ML solutions over to your company, and then train your company to of data scientists to be able to do that on a recurring basis.